So, to understand the difference between the smart grid and the conventional power system network, we can take one analogy, and that analogy is the human body. So, in human body, we have various sensors like ears, eyes, nose, which senses the environment and sends the signals to the brain. Brain processes that data, and finally, based on that processed information, brain decides the action. So now, if we remove brain from the body, then the data acquisition which the various sensors are doing will not have any positive outcome. So brain is considered to be one of the most important element of our human body for taking any decision. Similarly, in the power system network, there are various sensors like current and voltage sensors and so on, which keep on sensing the basic parameters from various parts of the power system network. And then there is a centralized processor, or we can say the centralized control center, which receives all those informations and process that information to take the necessary action. Now, the problem is with the current power system network is that the central control center is not strong enough to take smart decisions. So that's why the smart grid technology term was evolved to address the shortcomings which we are having in the conventional power system network. So during this particular course, we will understand the basic difference between the conventional power system network and the smart grid technology. So what we will study in this course, let's try to understand. So in this course, we will study these six broad topics. We'll start with the smart grid overview. Then we'll study about the smart grid architecture and design. Third topic which we will study is the smart grid measurement technology. In fourth chapter, we'll discuss about the smart grid communication technology. Then we'll discuss about the smart grid standards and protocol. And finally, towards the end, we'll discuss about the interoperability and associated standard. Now, in these six broad topics, what the various contents which we are going to study. We'll start with the smart grid overview. So in this title, we'll discuss about the history of smart grid, conventional grid, and smart grid difference. We'll discuss about the features of a smart grid, key characteristics of the smart grid elements, what are the forces behind the smart grid evolution, what are the various smart grid stakeholders, smart grid building blocks, and then smart grid resources. So these smart grid resources will work as a reference material for you to do further study in the smart grid technology. In the smart grid architecture and design, we'll discuss about the conventional power system architecture, how to place IT layer on top of it, how to use communication layer, and then we'll discuss about the distributed architecture design to realize the smart grid concept. So in this smart grid architecture and design, we'll discuss the overall architecture for the realization of smart grid concept. In the smart grid measurement technology, we'll discuss about the smart grid synchrophasor technology. We'll discuss about the smart meter and advanced metering infrastructure. We'll discuss about the wireless sensor network, and we'll discuss about the GIS and Google mapping. You might be wondering why GIS and Google mapping is part of the smart grid measurement technology. So when we'll progress in the course, we will discuss in detail why GIS or Google mapping plays very important role in the smart grid technology. As far as smart grid communication technology is concerned, we'll discuss wired as well as wireless communication technologies. In case of wired communication, we'll discuss various technologies such as power line carrier communication, Ethernet, optical fiber, and so on. In wireless communication, we'll discuss about various wireless technologies such as Wi-Fi, Zigbee, GSM, GPRS, and other wide area network related communications. We'll also discuss about machine to machine communication because in power system network, we acquire the data through machine and then machine sends data to another machine for the processing of the data. So machine to machine communication plays very important role here. Now, we'll also discuss about the various smart grid standards and protocols which we use for various communications. We'll discuss about various protocol overviews such as IC 61850, which is used for substation automation. We'll also discuss about the IC 60870, which is used for SCADA communication. We'll discuss about IEEE C37.118, which is used in synchrophasor technology. We'll also discuss IC 62351, which is cybersecurity standard for various power system protocols. We'll discuss IEEE 1588, which is nothing but precision time protocol. What is that? Basically, when you have to timestamp the various data at very high precision, we use precision time protocol. We can also say this is nothing but a time travel protocol. So we'll discuss in detail when we'll go towards the topic of smart grid standards and protocols. Then we'll discuss the DNP 3.0, which is again the SCADA communication related standard. We'll discuss IC 6197096 which is nothing but the common information model. We'll also discuss IC 62056, which is the communication standard for smart meter data communication. From interoperability and associated standard point of view, we'll first discuss what are the various issues related to interoperability in the smart grid, how to solve those problems, and what are the various standards which we can utilize to resolve the interoperability issues. So out of that, common information model, multi-speak, green button, SunSpec, and a smart energy profile 2.0 we will discuss in detail, and we'll see how we can solve the interoperability issue. Now, as far as the reference books are concerned, there are 6 commonly used books. These are Smart Grid Fundamentals of Design and Analysis by James Momo, Smart Grid Technology and Applications by Janaka Ekanaike, Smart Grid Standards, Specification, Requirements and Technologies by Takuro Sato, Smart Grids Fundamentals and Technologies in Electricity Network by Buchholz, Smart Grid Applications, Communication and Security by Lars T. Berger, and then Smart Grid Handbook, which is published in 3 volumes, written by Changqing Liu. So in this handbook, you will see a lot of case studies related to smart grid deployment across the globe.